Hello to you everybody, and we're starting with day three. This is last day, and we just have one topic today, that is Ngram models, and we'll finish with this. I will start with some sentences. Okay. So, what is Ngram models? Okay. So, models is, let's say we have first the sentence. This is a, and what will be there in the blank? Let's say I'm asking you this question. The Ngram models try to solve this. Okay. So let's say we are using a 4-gram model. 4-gram model means we'll take four words at the same time. So this is a what? So let's say what will be the probability that this word will be house? I should write like this. So out of this is house. How many times is there? One, only one time. There is only like one time is there. And what is the probability that there is this is a I think it should not be this is a, this is the, sorry. So this is the, so this is the, is in which sentences? This one, this one, this one, oh, and this one also. So four sentences, right? So uh, the probability of house being in this is basically only one, the first one. So 1/4. So this is some naive explanation that we did. Okay. Now there can be also, this is called a 4-gram, and there can be a bigram also. Okay. What is a bigram? Let's say if I say what is the probability that we'll have that jack after that. So so here if you notice, let me delete this 1 second. Yeah. So let's see how many words, how many have the word that. This one, this one, this one, this one. Right. So in all of the cases, you can see that jack is there. After jack, that there will be a jack. So in this case, it will be one probability. So after, if there is some jack, that word, after that there will always be jack. So something like this. Okay. So this is a basic, how can I call it? Like a very naive explanation of what I can give. Now let's try to understand this. So let's say there is this word W. So a W, mm, no, let's say there is a sequence of words, like a sentence, right? So W. So that can be W1, W2 till WN. So this is my sequence of words. We are defining this sequence of words. Okay. Now let's say if I want to find the probability of W, right? Probability of W. So we have to follow some chain rule according to Bayes theorem. So it will be what? P of W1 into P of W2 W1. Then what? Then what will it be the next one? P of W3 such that W2 till, sorry, W1 W2. Okay. Till we reach the P such that WK W1 W2 W K minus 1. So this is the probability. Okay. Now for smaller cases, this is really nice. Okay, this is really nice. But for larger cases, let's say case 1,000, how are you going to find this? You're going to die, right? It's not possible to find this plausibly, right? So we have to find the probabilities of such words many times, and this is computationally very hard. So that is when we do something called a Markov assumption. Assumption that says P of Wi such that W1, W2 till Wi minus 1, which is the last term, right? We can assume it to be P of wi by w minus n plus 1, sorry, wi minus n plus 1 till wi minus 1. So how do I realize this? What is n here? N is basically my n-grams n. So for, let's say, for bigram. So bigram, what will be the thing? So for my bigram model, it will become w equal to p of w1, p of w2, such that w1. Now what is p of 3? So p of it will become w of 3, then 3 minus 2, that is uh, 3 minus 2 plus 1, so that is w of 2. So on, if we go, it will become p of wk, such that k minus 2 plus 1, so wk minus 1. That's it. So this is my equation for a bigram model. So for let's say, if I wanted to find out what is the probability there is this is the house. Okay. So how will I find this out? It will become nothing but probability of this into probability of is after this, then probability of the after is, then probability of house after the. Okay, simple. So first one's probability 1 by 12, the second one's probability is 1 by 2. You can calculate it using this only, and it becomes 1 by 24. So we can easily find bigram probabilities like this. Okay. So yeah, so two things we usually change is that instead of starting it from nothing, we add a start token, and we also add a end token. It will become p of end such that wk. Okay, so so because we don't want to use w1 used throughout the corpus, we want it locally. Like that jack should be only calculated for the words where there are that. I don't want that jack for every condition, because there might be some that's there somewhere else. There might be some jacks somewhere else. I don't want that one affecting. So this is how ngram models work. So this is how your mobile autocorrect works usually. Okay. So it tries to predict what's the next word like this. So this is the overview. Now after this, what we have is basically we are going to do a small project, and that will be given as the project will be given as a assignment and in the notebook assignment, and you can try it out. It's a very interesting project, and you will use the learnings you have used till date in that. So let's finish this, and we have finished basics of NLP with this.